In 10.4, we are going to look more at the features of hyperbolas. The focal radius is given by c squared equals a squared plus b squared, as opposed to with an ellipse where it was a subtraction sign. The focal radius has to do with the foci. The foci have to do with the formal definition of hyperbolas. We're also going to identify the equation of the asymptotes, which when you look at it with the graph, it makes sense. Okay, so imagine this is my hyperbola. This is the center. The focal radius tells you the distance from the center to the foci. So there is always one in each half of the hyperbolas. So the point should end up somewhere in the two hyperbolic halves. Okay, so for the first one, it is not in standard form. So I'm going to convert it to standard form, and then I'm going to graph the foci in addition to the graph. Okay, so this is 4x squared minus 9y squared. Since both terms are squared and one of them is positive and one is negative, that indicates to me that this is going to be a hyperbola. There's no completing the square on this particular one, but I do need to make a 1 on the left side, right side actually. Okay, this is standard form. From here I can see that the center is 0, 0. The x radius is 3 and the y radius is 2. So I'm going to go ahead and draw the graph. Okay, x radius center 0, 0, 3, 3, 2, 2. I'm going to use the box to help me get my asymptotes looking nice. I'm going to find the asymptotes too. Okay, now my asymptotes go through the corners of this rectangle. Okay, now let's see. The x squared over 9 is the positive term, which means this is opening in the x direction. Okay, and I am approaching my asymptotes on the sides of each of those curves. Okay, let's look at the features now. The vertices are this point and this point. Because the x radius was 3, this is 3, 0 and negative 3, 0, which the lazy way to write this would be like this. Okay, let me see. I'm going to write the equation of the asymptotes as well. If I just looked at the graph, I could tell the equation of the asymptote. The y-intercept 0, 0. It goes up 2 over 3, so this is y equals 2/3 x. The other asymptote would be going down 2 over 3, so the other asymptote would be y equals negative 2/3 x. If I use the formula, this is just point slope form, where it's using the center and the slope to write the answer in point slope form. I'm okay with you leaving it in point slope form or in slope intercept form, or whatever appropriate form you can think of. So in point slope form, y minus 0 equals plus or minus the y radius is 2, x radius is 3 over x minus 0, which again is the same as plus or minus 2/3 x, which is completely consistent with our graph. Up 2/3, down 2/3. Okay, now the foci. The formula for the foci of a hyperbola is c squared equals a squared plus b squared. Because we are adding them, it doesn't actually matter which one is a or b, whereas on the ellipse it did because we didn't want to get a negative value. Let's see, a squared is 9, b squared is 4. So the focal radius is the square root of 13. Okay, the foci should end up inside the two hyperbolic halves. So the square root of 13 is 3 point something, 1, 2, 3 point something. So it ends up here, 1, 2, 3.7 something ends up over here. So one of the foci is here, one of them's here. It makes sense that they end up inside the hyperbola halves. If they didn't, I would assume I made the wrong formula. Okay, so from the center, I went right, the square root of 13. And then from the center, I went left, the square root of 13. So these are the coordinates of my foci. Okay, I'm going to go ahead and do the same thing for this example, except for I am going to have to complete the square. Okay, before I even start though, I'm going to think about which shape it's going to be. I see there's a 25x squared and a minus 9y squared. Since both the x and y squareds are x and y's are squared, this could be a circle, an ellipse, or a hyperbola. Because this one's a positive 25x squared and this is a negative on the y squared, they have opposite signs, which makes it a hyperbola. Okay, I'm going to go ahead and solve this just like I did with the ellipse. Okay, let's see. I have 25x squared minus 200y. I'm going to go ahead and factor out the 25, which is going to take me down to 8x. I am going to complete the square in a second. Okay, let me go ahead and do the y term. So I have a minus 9y squared minus 36y. I know I'm going to have to factor out the minus 9, so I'm going to do it now. If I factor minus 9 out of minus 36, I get plus 4y. Okay, and I am going to move the plus 589 to the other side by subtracting it. Okay, now I'll go ahead and complete this square. So half of 8 is 4, 4 squared is 16. Half of 4 is 2, 2 squared is 4. And then remember to balance this out, I do have to add it to the other side. So in this case, 25 times 16, and then be careful, that's a minus 9 times 4. Okay, let me continue this problem. Okay, I'm going to go ahead and add up all the numbers on the right side, which gives me negative 225. Okay, so I can see the center already. I just need to turn this into a 1. Okay, and do be careful with your signs. Okay, so I have the x minus 4 squared in the numerator. If I do negative 225 divided by 25, I actually get negative 9. Okay, let's see. I have y plus 2 squared. Since it was negative 225 divided by negative 9, it's turning it to a positive 25. Okay, let's see. The center is 4, negative 2. The x radius is 3. The y radius is 5. This negative is just telling you which way the hyperbola is going to open. It's not going to open in the x direction. It is going to open in the y direction because the y is positive. Okay, let me go ahead and graph this. Okay, so I did my x radius as 3, my y radius as 5, and I'm going to go ahead and create the box to guide my asymptotes. Make sure your asymptotes are longer than the box because they need to guide the parabola outside the box, not inside the rectangle. I'm a little crooked. Okay. Let me see. This is opening in the y direction because this is the positive term. Make sure your hyperbola is approaching the asymptotes, not curving inward or doing weird things. Okay, let me look at the vertices. Vertices are here and here. So the center was 4, negative 2, and I went up 5. So 4, negative 2 plus 5 is 3. 4, negative 2 down 5 is 4, negative 7. Okay, now for my asymptotes, I'm going to go ahead and use point slope form. Okay, let's see, the center is at 4, negative 2, so y plus 2 equals plus or minus the y radius over the x radius times x minus 4, which makes sense because this is 4, negative 2, The slope is up 5 over 3, or the slope is down 5 over 3. Okay, now my focal radius. Okay, the focal radius is the square root of 34. They should be opening, they should occur inside each of the hyperbola halves. So from the center, I'm going to go up, what is that, 5 point something, not quite 6. 1, 2, 3, 4, 5 point something. So around here. Around here. If they don't end up inside the hyperbola, then you probably used the wrong formula. Okay, now let me write the coordinates for my foci. I'll put them over here. Okay, let's see. My center was 4, -2, and then I went up the square root of 34 to get F1. And then for the other one, I started at 4, -2, and I went down the square root of 34 to reach my second foci, although it doesn't matter which one's first or second. Okay, for the second example, we're going to try to write the standard form of a hyperbola using the clues that they give us. And there's more than one way to do it, but you do have to kind of reason this out. Okay, so for A, it tells me the vertices are 0 and plus or minus 3. The foci are 0 and plus or minus 5. I want to figure out the equation. Okay, it is a hyperbola. Let's see. Is this opening in the x or y direction? Okay, if the vertices are at 0, 3, and 0, -3, this must be opening in the y direction. I could also get that from the foci because the foci occur inside the hyperbola halves. Okay, now I need to figure out the center of this hyperbola. Okay, if one of my vertices is at 0, 3, and one of mine is at 0, -3, it makes sense that the center would be 0, 0. For those of you who would prefer to use a formula, I could use the midpoint formula because the vertices in between the two vertices will be the center. So the midpoint formula would be to do the x plus the x divided by 2. What are the y's? 3 and -3. The y plus the y divided by 2. So the center's at 0, 0, and it opens in the y direction. So now I know that this is going to be positive y squared, negative x squared. Since it's in standard form, I also know it needs to equal 1. Okay, let's see what other information I can get. Let's see, I need the ry and the rx. Let's see, the the vertices are at 0, 3 and 0, -3. The center is at 0, 0. So from 0, 0 to 0, 3 is 3 units in the y direction. So that's giving me the next clue that the ry is 3. So now I know there's going to be a 9 under here. So I just have one more piece of information I need to figure out. What else did they give me? They give me the foci. Okay, the foci are at 0, 5, and 0, -5. Because the center is at 0, 0, and the foci is at 0, 5, it must be true that the focal radius is 5. I don't want the focal radius, though. I want the y radius. But I know that for a hyperbola, c squared equals a squared plus b squared. So 25 equals, now I don't know if 3 is the a or the b, but it doesn't actually matter because they're being added together. 3 squared is 9. Okay, so I know that the other radius is 4. Since the only radius I don't know is the x radius, it must be true that the x radius is 4. So 4 squared gives me a 16 here. Okay, and then that's my hyperbola in standard form. It should meet all the requirements that we just read. Let's try a couple more using different information. Okay, let's see, B, they give me the vertices and the foci again. That seems reasonable. Okay, it is a hyperbola because it told me it's a hyperbola. Let me see if it's opening in the x or y direction. Okay, the vertices are at 5, 1 and -3, 1. Okay, so the y value is not changing. Only the x value is changing, which tells me this is opening in the x direction. Okay, let me find the center, and then I can at least start this. Okay, now the vertices are at 5, 1 and negative 3, 1. If you can think in your head, you might be able to figure it out. I could use the midpoint formula. If I add the x's together and divide by 2, add the y's together and divide by 2, although the midpoint of 1 and 1 is 1. Okay, what do I get? 5 minus 3 is 2. 2 divided by 2 is 1. 2 divided by 2 is 1. Okay, let me just make sure that makes sense. Is 1 between negative 3 and 5? Yes. Is 1 between 1 and 1? Well, yeah, kind of. Okay, and this is opening in the x direction. So x minus 1 squared over the rx squared minus y minus 1 squared over whatever the y radius is squared equals 1. And I made this the positive term and this the negative term because it's opening in the x direction. Okay, now let me see. What do I need? The x radius and the y radius. Let me look at the vertices. Let's see. One of the vertices is 5, 1. So if I go from 1, 1 to 5, 1, I'm going 4 units in the x direction. So it must be that the x radius is 4. Okay, do they give me, again, they don't give me the y radius, but they do give me the foci. Okay, so for the foci, I have 7, 1 and negative 5, 1. Okay, if the vertex is 1, 1 and the foci is 7, 1, from 1, 1 to 7, 1, I have to go 6 units. So it must be true that the focal radius is 6. Okay, so c squared equals a squared plus b squared. 36 equals, I don't know which one's a or b, and it makes no difference. Okay, now I could square root this if I want, but I'm going to re-square it anyways when I plug it back in. So I'll just put the 20 here now. And this should meet all the requirements of what we were trying to, of the given information. Okay, last example, and they are giving me the asymptotes this time, but I still have the vertices. Okay, so I'm going to go ahead and see which way it's opening first. Negative 3, 9, negative 3, 2. Since the y values are the ones that are changing, this opens in the y direction. Okay, they gave me the vertices are negative 3, 9, and negative 3, 2, which means the center is negative 3 comma something. Let me use the midpoint formula to figure it out. Actually, make that negative 3, 8, because I'm going to make it easier. Okay, negative 6 divided by 2 is negative 3. 10 divided by 2 is 5. So the center is negative 3, 5, and it opens in the y direction, and I know it's a hyperbola. So y minus 5 squared, x plus 3 squared equals 1. Okay, now let me look at the vertices. Since this opens in the y direction, I should be able to figure out the y radius. So from negative 3, 5 to negative 3, 8, I have to go 3 units in the y direction. So the ry is 3, which I square and put there. Okay, now what do they give me? They don't give me the focal radius, they give me the asymptotes. Okay, the main thing I care about with the asymptotes is the slope, because the slope is going to be plus or minus ry over rx. Okay, so what do I have? I know the slope is going to be either 3 halves or negative 3 halves. I'm going to use the positive one. Okay, so the slope is 3 halves. This is going to equal to ry over rx. I know the ry is 3. I mean, this is kind of a 1-to-1, so I can tell that the rx is going to be 2. If it was not that obvious, I might cross multiply. But either way, the rx is 2, so when I square that, I get 4.